So we're going to find the area of the region enclosed by y equal 2x, which is a line, and y equal x squared, which is a parabola. All right. So y equal 2x. I'm not drawing this perfectly, but whatever. Y equal 2x goes through the origin, slope 2, y equal x squared, comes up, and keeps going like this. They're going to cross in 2 points. So this is y equal x squared here. And I want to find that region R right there. Okay, so they cross at 0, 0. And, okay, where else do they cross? 2x equals x squared when x equals 2. So 2, 4 be the other place that they cross. Okay. Let's see here. Do we want to do x easy or y easy? How about, I think if I do y easy, that works. It's the left is always the left and the right is always the right, same equation. But also notice if I do x easy, is the top always the top? The bottom always the bottom? Yeah. So this is going to work both ways. So I think it'd be good for us to just practice integrating both ways. So let's integrate dy dx first, and then we'll integrate dx dy, and we'll make sure that they get the same answer. It'd be good practice for us. Remember, the hardest part is finding the bounds. Once we get the bounds, the integration is pretty easy. It's integrate 1 is just y, right? And it's not hard to integrate, okay? The hard part is getting the way that they're set up correctly. Okay, so what does this say to integrate with respect to first? Y. So y goes from curve to curve. Okay, so my curve is in terms of x, meaning y equals some function of x, okay? And so over here, y equals some function of x. So y, the y value, the height, is stuck between two things right here. So I already have y equals 2x and y equals x squared, so I'm good to go. The low side is y equal x squared. Right, it's bounded below by that curve, and it's bounded above by y equal 2x. All right, so that's probably the easiest way to do it right there. So I go curve to curve, and then I go point to point. So my x value is stuck from point to point. So the x value, right, what is the lowest x value that I attain? The lowest x is going to be at 0, and I get all the way up to the biggest x, which is 2. Okay, so all my x values range from 0 to 2. So point to point is from 0, x equals 0 to x equal 2. So how do I integrate this? Integral from 0 to 2, and then x squared to 2x of 1 dy dx. Okay? Whenever I integrate this, what do I get? Integral 0 to 2 of y from x squared to 2x dx. And this is 0 to 2 of 2x minus x squared dx. So that's x squared minus x cubed over 3 from 0 to 2. Okay, 4 minus 8 over 3. 4 minus 8 over 3, and then minus 0. Minus 0. So that's going to be 4/3. Okay. All right. So now we're going to take, instead of doing it with dy dx, let's try to do it integral over the region of dx dy. Okay, dx dy. So let's take that same picture and bring it down here so we don't lose it. All right, let me clean this up a little bit. Okay, so dx dy. So dx, I need curve to curve. X is from curve to curve, so that's h1 of y to h2 of y. And then, so that's curve to curve. And then, so the x value from curve to curve, the x value ranges from what to what? The low side is this thing right here, but I can't put 2x. Remember, curve to curve, h1, this is x equals h1. X is a function of y. So how do I rewrite that? So how do I get x equals something here? I divide both sides by 2. So x is equal to y over 2. So y over 2. Okay, so that's the low side. Now the high side is what? Ooh, I have y equals x squared. Okay, square root this. But whenever I square root, I get a plus or a minus. So how do I know which branch I'm on? Well, this is the positive side of the square root of y. This is the negative side over here. So I'm dealing with the positive side on the right side. Okay? That positive side, square root of y, there. All right, so that's curve to curve. And then I want point to point. So y spans from point to point. So from C to D, that's my point. Okay, the lowest y value to the highest y value. So lowest y value is 0, the highest y value is 4, right? Okay, so from 0 to 4. So now I'm going to integrate from 0 to 4, and from y over 2 to square root of y of 1 dx dy. And when I do this, I get 0 to 4. Integral of 1 with respect to x is x. Y over 2, square root of y, dy. F of b minus f of a, which is square root of y minus y over 2, dy. Okay, y to the 1/2 integrate, add 1 to it is y to the 3/2 divided by 3/2 is multiplied by 2/3. So that's the integral there. If I integrate that, I get 2 over 3, y to the 3 over 2, minus add 1 to it, y squared over 2. 2 and 2 is 4. 0 to 4. Do the math there, you're going to get 4/3 again, which is what you want. All right. So we're going to continue this theme of rewriting, and it's just going to help us get better and better. If there's one thing I want you to walk away with, the most important thing from this section is learning how to rewrite these iterated integrals, because when you learn how to rewrite them, you're going to get better at finding that region bounded between the curve to curve and the point to point. And that's what we're trying to get home, because we're going to use this for the rest of the semester. We're going to use it all in chapter 13, and it's going to pop up again in chapter 14 when we're trying to restrict. Not only do we have double integrals, but we're going to have triple integrals. Okay, so this stuff isn't going away. So we've got to get good at defining our regions. Okay, defining our regions. You give me a curve, I tell you the curve, give me point to point, and then I draw that region R. That's what we're trying to get good at. All right, so here's an example. Rewrite. So this one, we don't actually have to solve the iterated integral, we just want to rewrite it. So rewrite the iterated integral from 0 to 6, from 0 to x over 3 of 1 dy dx with the order of integration dx dy. Okay, so all we did is we swapped it around. I'm going to integrate with respect to x and then with respect to y. So how do we do this? My suggestion would be to figure out what that region is. Okay, and we do that by focusing on, first I integrate with respect to y. So curve to curve, okay, it's bounded by what? Y is between two functions of x, 0 and x over 3. So I have y equal to 0 is a curve, and y equal to x over 3 is a curve. Okay, so if I draw that, so the x-axis and the y-axis, y equal to 0 is it's the x-axis, isn't it? Okay, and y equal to x over 3 is going to look like this. Y equals x over 3, like that. Okay? And then it's bounded from what? Point to point. So from x value 0 to x value 6. So x value 0 to x value 6. So the region is right here. So this is my shaded region right there. All right, that's my R. Okay? All right, so what do we want to do? We want to rewrite it as the integral, double integral over the region R of dx dy. So I want x to be from curve to curve. Okay, so we integrate curve to curve for x first. So x needs to be between two functions in terms of y. All right? Well, how do we do that? So x runs from left to right. Is it always the same left to right? Yeah. All right. The left side's always the left side. The right side is always the right side. So we're good here. Okay. So the x value goes from, okay, what is this over here? This is y equals x over 3. Well, I can't put x over 3. I've already got x in the middle here. I need it in terms of y. So solve for x. X equals 3y. So the low side is 3y. Okay. Over here, I just have x equals to 6. Okay. Well, x equals 6, that's a function. That's x equals h of y, isn't it? Okay. Or h of y is just 6. All right. So x is always 6 on that side. All right. Now I need from point to point. So I need the y value from point to point. Okay. So the y value from point to point, the lowest y value, it never goes below 0. And then the highest y value, well, when x is equal to 6, what is that point up there? Y equals 6 over 3, which is 2. So the highest y value is 2. So y ranges between 0 and 2. Okay? So to rewrite this, it would be from 0 to 2, and then from 3y to 6 of 1 dx dy. Okay? So that's how we rewrite it. All right, so this integral can be rewritten as this, and those two things are equivalent to each other. All right, let's try with one more. Make sure we got this, and then we'll be done. Yeah? Yeah, this is the last problem right here. Okay. Rewrite integral 0 to 1, integral 5 minus 5x to 5 minus 5x squared, 1 dy dx. Okay, dy dx. With order of integration dx dy. All right. So 5 minus 5x is a line, okay? And 5 minus 5x squared is a parabola. Remember, I'm integrating first with respect to y. So y is stuck between two curves. It's stuck between 5 minus 5x and 5 minus 5x squared. So remember, this is y equals, g2 of x. This is y equals g1 of x. Okay, function y is a function of x for these from curve to curve here. So let's draw this. So 5 minus 5x, so I'm going to cross at 05, okay? I'm going to go down a slope 5. So after I cross through here, okay, it's going to cross through at 10 like that, okay? And then parabola, it's a sad parabola, negative 5 in front of the, or is coefficient for x squared, so it's excuse me, concave down. And so start at when x equals 0, we get 5, and so then it's going to curve down like this and crosses through. That's mighty convenient. All right, so my region R is that little region right there. So whether we did y easy or x easy, the top's always the top, the bottom's always the bottom, the left's always the left, and the right's always the right. We're only going to have to do one integral to rewrite this, so that's good. Okay. We're bounded between what and what? the x values are bounded between 0 and 1, which makes sense. Okay, 0 and 1 for the x values. So it's this little sliver right here. We need to rewrite it. Okay, so we want to rewrite it as integral over that region, dx dy. So we need our x to be from curve to curve. Okay, so x from curve to curve. So the low side looks like this line here. Now, right now we have y equals 5 minus 5x. But we need this thing to be in terms of y. In terms of y. Okay, so how do I do that? I solve for x. If I solve for x, I get 5x equals 5 minus y divided by 5, divided by 5. So it's going to be 5 minus y over 5 to, okay, the other side, what do we have? Y equals 5 minus 5x squared. Okay, to solve for this, I'm going to move 5x squared over here. I'm going to subtract y over here, divide by 5, divide by 5. So I get a square root plus or minus 5 minus y over 5. Now, which side of the parabola am I on? Am I on the negative branch, 5 minus y over 5, or I'm on the positive branch? I think I'm on the positive side. Okay. So I've got square root positive branch, 5 minus y over 5 here. Okay. So that's curve to curve. Now, point to point, I need the y value between 2 points. The lowest the y value gets is 0. The highest the y value gets is 5. So 0 to 5. So I wasn't asked to solve it. I was just asked to rewrite it. So 0 to 5, and then 5 minus y over 5 to square root 5 minus y over 5, 1 dx dy. And that's equal to the region R. All right? So the better we get at rewriting these, the better it's going to serve us in the future when we get to the more complicated problems. All right, guys, don't blow this off. Try to work through this.